for the opportunity to visit with you folks today about restoration of frequent fire forests and managing for resilience, a science basis. Before going into that in some detail, let me just review the author group that prepared this GTR 310, so folks will be aware of that. We have Dr. Richard Reynolds from the Rocky Mountain Station, who's worked with the region for well over 20 years in habitats and restoration of forests, a lot of which is related to the northern goshawk. We have Andrew Sanchez-Metter, who's an assistant professor at Northern Arizona University and also a member of ERI. Jim Utes, our regional silviculturalist here in the Southwestern region. Don DiLorenzo, recently retired director of wildlife, fish, and rare plants in the region. Tessa Nicolay, our fuels and fire ecologist stationed over in Arizona. Andy Graves, our insect and disease individual here in the regional office. And this is Pat Jackson speaking. I'm also retired most recently here in January. And finally, and certainly not last or least, Megan Matonis, who is a PhD candidate at Colorado State University and also works with the Rocky Mountain Station. I think she provides adult supervision for Richard and others in the station. With that, let me just sort of launch into the presentation, Xander, unless there's any other housekeeping that we need to do.
No, that's great. Go for it.
Okay. We'd like to have a dialogue with folks today about the region's focus on restoring resilience and sustainability in our southwestern frequent fire forests. And we want to center that dialogue around GTR 310, which is titled Restoring Composition and Structure in Southwestern Frequent Fire Forests, a Science-Based Framework for Improving Ecosystem Resiliency. Now, let me emphasize, when we talk about frequent fire forests here, we're talking about ponderosa pine and dry mixed conifers in the Southwest. Our objectives are to enter this dialogue related to restoring resilience in frequent fire forests centered around 310. We want to talk about the science basis and restoration objectives that are described in the document, management recommendations and their applications, and our view of collaboration based on an ecological starting point versus a social need. In order to do that, I'd like to summarize some regional accomplishments and the path forward with respect to restoration of these critical landscapes in the Southwestern region. I'd like to do this because I think it demonstrates the commitment to restoration of frequent fire forests. Since 2009, we've held over 15 workshops and dialogues in the Southwestern regions, both internal and external, with folks to enter into discussions about what these forests ought to look and function like when they're restored. We've developed some showcase projects at Blue Water and Eager South to demonstrate actual treatments on the ground. We've developed a landscape scale NEPA analysis for the 4-Fry project in northern Arizona, which covers 900,000 acres, and we're working on a similar NEPA project in southwest Jemez for over 200,000 acres. So they're much larger areas going through NEPA than we've ever done before. In addition, we have a large landscape scale stewardship contract in northern Arizona on the 4-Fry project that will allow us to contract for 300,000 acres of mechanical treatment over a 10-year period, the largest stewardship contract in the agency to date. And finally, our publication of GTR 310, described here in this slide, in September 2013. Thank you. Well, what would a frequent fire forest look and function like when it's restored? What is our vision for improving ecosystem resilience in frequent fire forests? And what does the path to this vision look like? GTR 310 is the culmination of our work to date to define and describe what frequent fire forests should look and function like when they're restored. It's a synthesis of relevant science, including forest ecology, forest management, disturbance science, both fire, insect and disease, wildlife ecology, and biological diversity. The authors of GTR 310 are specialists in these areas. As such, GTR 310 paints the vision of a restored frequent fire forest based on the best available science. It went through extensive peer review, both blind and courtesy, including forest ecologists, fire ecologists, wildlife ecologists, and disturbance scientists. Go ahead. In order to describe this situation in the region, I thought it would be useful to talk about our forest veg management practices since World War II up to the present, and sort of trace our evolution of forest management in that context. First, we have an anthropogenic reduction in fire frequency, where we reduce the frequency of fire through grazing, row building, and fire suppression. Our first generation of forest plans that were generated in the 1980s emphasized even age management and focused on timber production. We shifted from that emphasis on uneven age management in 1996 when we amended our plans in order to conserve the northern goshawk and the Mexican owl. This shift to uneven age management was driven by a lack of regulatory mechanisms for the Mexican owl and the northern goshawk. In the late 1990s and early 2000s, we shifted to a fuels-focused management approach in response to large uncharacteristic fires. This was still an even age management approach with lots of thinning from below. Many of you can remember the Rodeo Chetasky fire in Arizona, which is one of the big fires that motivated this shift. Since 2006, we have been preparing for another shift in focus. This shift is toward restoration, restoring resilience and sustainability of these forests while meeting our fuels objectives. This shift toward restoration is our topic for today as we consider the vision of restored forests in GTR 310. Go ahead. Okay, unhealthy forest conditions. Our forests today are overstocked. They're predominantly mid-aged, continuous canopy, way too dense. They're significantly departed from historic condition, or as some of the team members used to say, they're out of whack. We need to do something about them. This is demonstrated by uncharacteristic disturbances of fire, insect, and disease. The fire resulting in loss of property, habitat, and ecosystem services. And of course, the reduction in interspace grass forb shrub resulting in the loss of biological diversity. Go ahead. An example of these large uncharacteristic fires is the Las Conchas Fire, which started in the Jemez Mountains in 2011 west of Santa Fe. It burned 156,000 acres, over half of which was in high to moderate severity. It resulted in significant reoccurring flooding and watershed impacts to many communities. In fact, we're still struggling with the impacts on the Cochiti Pueblo today. This significant damage to watersheds, ecological resources, and downstream communities is a clear indication we must get on with restoration. Okay, restoration. Forest Service. The Forest Service mandate on restoration is not new. We have statutes which prescribe that we should do restoration. The CFRP, which is applicable to New Mexico in 2001, HFRA in 2003, the CLFRA statute in 2010. In addition, the Secretary of Agriculture has provided emphasis to pursue restoration. In speeches, he's given the agency direction to move forward with restoration and protect watersheds. We have an agency policy in Forest Service Manual 2020 to restore lands, which requires each regional forester to establish a strategy to do so. This region has a landscape scale restoration strategy for all lands, which has resulted in the CLFR projects for Fry, Southwest Jemez, and the Zunis. It resulted in restoration dialogues from 2009 and 10 to the present, and GTR 310, which charts the path to achieve our vision of restored frequent fire forests. Now, why are we focused on frequent fire forests? Well, we're focused on them for three reasons. They're the most departed and at-risk systems that we have. They're also one of the most abundant, and they are adjacent to the communities in the Southwest, the wild and urban interfaces. Luckily, we have a large body of science in these areas. We have historic range of variability science, we have reference conditions and reconstructions, disturbance science, and biological diversity. Let's start with historic range of variability. Why not let recent history be a yardstick to compare ecological status and change by assuming recent historical variation represents the broad envelope of conditions that support landscape resilience and self-organizing capacity? HRV is that broad historical envelope of possible ecosystem conditions such as fire frequency, tree density, species composition, or patch size distribution used to provide a representative temporal range of reference conditions commonly used to guide land management. HRV assumes five things. First, ecosystems are dynamic. They're not static, and their responses to changing processes are represented by past variability. Secondly, ecosystems are complex and have a range of conditions within which they are self-sustaining, and beyond this range, they transition to disequilibrium. Three, historical conditions can serve as a proxy for ecosystem health. Four, time and space domains of HRV are sufficient to quantify variation. And finally, the ecological characteristics being assessed for the ecosystem or landscapes match the management objectives. In this GTR, we refer to HRV as the variation of historical ecosystem characteristics and processes over varying time and space scales that are appropriate to inform and guide management actions. Go ahead, Jim. Next, reference conditions and reconstructions. There are several sources of reference conditions, time frames, and temporal spatial resolutions. These include natural archives that are recorded by Earth systems and processes such as plant growth cycles, tree rings, etc. Documentary archives are written, tabulated, mapped, or photographic records, such as historical plot measurements. Reconstruction of environmental conditions which use both natural and documentary records as well as statistical models. Numerous forms of science were considered, but GTR 310 was informed heavily by reconstructions. Disturbances. Characteristic disturbances created and maintain the structure, composition, and spatial arrangement of frequent fire forests. These primary characteristics are fire, insect, and disease. Evidence of these past disturbances are informed by dendrochronology, epidemiology, biogeography, and others. Biodiversity. It's just the numbers of plants and animals and processes and functions in a particular area. Forests, by their nature, are diverse and complex ecosystems, providing habitats for many plants and animals. Habitat diversity, the variety of places where organisms live, is a driver of biological diversity. Biologically diverse systems are more productive, thereby support more robust food webs and trophic interactions. Biodiversity and landscape ecosystem approaches. Go ahead, Jim. Single species habitat management will not sustain ecosystems. Native species are adapted to historical forest composition, structure, and disturbances. Thus, an ecosystem approach based on restoration of temporal and spatial dynamics, processes, and functions of forests, such as evolutionary environment, implemented at a landscape scale should provide for native biodiversity. Okay, let's shift gears and talk about the content of GTR 310 a minute. It provides a synthesis of the ecology of frequent fire forests focused on these characteristics: the composition of them, the structure, their processes, and their function. It describes a framework for implementation of the science that identifies research needs. As such, it's a guide to restoration of frequent fire forests. Now, it's intended as a guide. It does not mandate a particular outcome. It is not manual direction or direction the agency must follow. I think of GTR 310 as a starting point that we should keep in mind as we build restoration projects. As such, in my view, it's the centerpiece of restoration. Okay. Let's get into the key elements of frequent fire forests and their habitats in terms of three items: the tree species and age compositions, the spatial characteristics of the forests, and their processes and functions. First, species composition. These frequent fire forests are characterized by fire-resistant, shade-intolerant tree species, and they're dominated by them. They have characteristic grass-forb shrub communities between the groups and individual trees, and they have below-ground species. This photo shows a system that's closed in with more and more shade-tolerant species. You can see the oak in the foreground being overgrown, and you can see the lack of grass-forb shrub because of the shading. Next. Spatial and age characteristics. Trees are grouped with interlocking crowns. Interspace between the tree groups is evident. You can see that in the white background between the shaded tree groups or individual trees. All tree age classes and as much old forest as is ecologically sustainable, and a high interspersion of tree age classes. This forest structure and arrangement of trees allows sunlight to reach the forest floor, which results in grass-forb shrub occupied openings, and to allow tree group root spacing and tree regeneration. This spatial and age structure provides for greater plant and animal diversity than current conditions. Now, not all trees are grouped. On wetter sites, trees will have a tendency toward random spacing and less aggregation into groups. In addition, patches larger than groups of closed forest structure will occur, reflecting natural biophysical site conditions and habitat needs for T&E and sensitive species. Tree groups and size and variability. Tree group size ranges from 1/10 of an acre or just a few trees to 3/4 of an acre or more with 40-plus trees in a group. Group size is highly variable based on site conditions. You can see the white background is the grass-forb shrub interspace. The groups are in the yellow shaded areas, and you notice the tree cover in the figure delineated by the yellow shading and the variability highlighted by the red outline. The variability of tree group size is quite broad. Okay, openness variability. This is an example of a north slope in a dry mixed conifer site on the Cleveland National Forest. And I show this to illustrate that on the north slope, we have 30 to 40% of an area in open grass-forb shrub, 70 to 60% of the area under mid to old tree cover. The next slide shows the variability on a south slope with 40 to 60% of the area in open grass-forb shrub interspace and 60 to 40% under mid to old tree canopy. This illustrates the variability in the size of the groups and the interspaces between them. Okay, any discussion of restoration of these frequent fire forests wouldn't be complete without talking about scale. So this particular figure shows characteristic vegetation patterns at 3 spatial scales. The landscape scale, the upper left-hand corner, illustrates the multiple stands and natural meadows and grasslands. The mid and fine scales below them illustrate the grass-forb shrub interspaces, uneven age stand conditions consisting of single and group trees of different vegetation structural stages, young to old, represented by different shades and sizes. The landscape scale is 1,000 or more acres. The mid scale is from 10 to 1,000 acres, and the fine scale is up to 10 acres. Meadows and grasslands within the forested type in the upper part of the figure on the landscape scale are included at the landscape scale, and they're usually a function of different soils than forested areas. The grass forb shrub interspaces, areas occupied by grass forb shrub not intended to be occupied by tree canopy at the fine and mid-scale, have gaps between trees and individual trees not under tree canopy. Their major contribution is to the biological diversity and they're critical for carrying fire on a natural basis in the mixed conifer and ponderosa pine. Okay. Old forests. Other key elements, old forests. Old forests, or as much old forest as is sustainable. It's extremely important to have all the age classes in this system, including the older trees. These large trees are well distributed in the landscape and provide for sustaining well-dispersed snags, large logs, and woody debris. Go ahead. Shaded forest habitats. Trees are grouped with interlocking crowns. This provides tree-to-tree movement for tree squirrels, denser cover for plants and animals, provides shading and mesic soil conditions for fungi and other organisms, both game and non-game. Habitats, interspersion at the fine scale. There's high tree age class interspersion within the grass forb shrub habitat. This is important. It provides habitat adjacency to the areas that are critical to wildlife and provides sustained desired habitats and increased biological diversity. Dead and decaying wood. These large tree components provide for snags, logs, woody debris, and nutrient cycling, which is critically important, this large tree habitat components for many species in the food web, and including nutrient cycling. Let's shift gears and talk about ecological processes. These systems are frequent surface fire systems, with fire reoccurring in ponderosa pine every 2 to 26 years, and in dry mixed conifer every 4 to 32 years. They consistently have endemic insect and disease activity. Now, fire is the dominant recycler of nutrients in the ponderosa pine and a driver of horizontal and vertical structure, understory composition, productivity, and quality. GTR 310 acknowledges and features natural surface fire as a critical function within these veg types. Our goal is to return characteristic fire to the system, not exclude it. Fire is a critical tool needed to achieve our restoration vision. Sustainability, approximate balance of age classes. Our vision includes continuous aging of tree groups from young to old. Represents a shifting mosaic of ages at the fine and mid-scale over time. This photograph illustrates characteristics of restored ponderosa pine forest with multiple ages of tree groups, interspersion of tree age classes, interspaces of grass forb shrub, and we would expect dry mixed conifer to be very similar. Outcomes of restoration. Well, one of the most important ones is the resumption of frequent low-severity fire and increased flexibility for the use of fire as a management tool. So we're looking for frequent low-severity fire, not what you see on the upper right, which is uncharacteristic fires that are very destructive. Another outcome is increased resilience to disturbance and climate variability, not what you see on the right with regard to insect outbreaks. Now, what we're shooting for is fire that occurs on the surface and is of low severity. Another very important outcome is the resumption of the feedback loop between the composition, structure, and fire in the forests. Go ahead. Outcomes continue. Improved plant and animal habitats, improved biological diversity, and improved food webs. Sustaining old growth, characteristically there is before we changed the systems through our actions. Restored hydrologic function. These systems, when they're treated and restored, will have greater moisture hitting the forest floor, improved infiltration, and greater contribution to stream and spring flow. Sustainable wood supply over time. Improved forage production. When we open these forests up, we get improved forage production. Enhanced visual quality. The visual quality associated with a multiple aged forest with grass shrub interspace has a great deal more variety to it and is visually more pleasing. And of course, fuels reduction. Now, some of you might be wondering about climate change. What do these outcomes do with regard to climate change? Well, restoration of composition, structure, and function in frequent fire forests, in our view, is the best option for enhancing ecosystem survival and retention of component species in the face of increasingly frequent catastrophic losses, which provides more time for research and management to develop options for future climate conditions, and increases ecosystems' resistance, resilience, and responses to future climates by forestalling impacts, improving recovery after disturbances, and allowing species to adapt in place or migrate to new conditions. Let's go ahead. I'd like to give an example now here of a treatment area that we did in the southwestern region called Eager South. This particular area is located along the road to Big Lake, south of Springerville, Arizona, on the Springerville district of the Apache Sitgraves National Forest. The left-hand photo is the Eager South pre-treatment photo of a post-fledgling area treatment. And the right-hand photo is the post-treatment photo, and this area was treated in 2008. We reduced the basal area in the Eager South PFA from 120 square feet of basal area down to 70. You can see the more openness of the system in the right-hand photo, the grouping and clumping of individual trees. And Jim, up to the right, in sort of the center of the picture, if you just identify the location of the northern goshawk nest, that would be great. It's right in there. Right there. This area had a northern goshawk nest that had not produced young at the time of the treatment, but post-treatment it did produce 2 young in 2009. Okay, I'd like to go to the next photo then and talk about this same area. The left-hand photo is the pre-treatment, and the right-hand photo is after the Wallow Fire. Now, the Wallow Fire occurred in June of 2011. It burned almost 500,000 acres over the month of June. Extremely aggressive fire, uncharacteristic fire, crown fire in many areas. It entered this particular treatment area from the southwest of the lower left-hand corner and burned to the northeast up to the upper right-hand corner. You can see Jim has just circled the areas that were totally destroyed by the fire. This fire entered the area with 60-mile-an-hour driving headwinds. It was a crown fire. It jumped across the road into the treatment area. There was no burning out or protection of this area beyond the actual treatment itself, done in 2008. It burned into the area, and there was about 150 feet of scorch kill immediately adjacent to the road. The fire then dropped to the ground and burned on the ground all the way through to the northeast, went back in the crowns and proceeded towards Springerville after it finished the treatment area. Very, very uncharacteristic fire. Go ahead, Jim. These 2 paired photos here show Eager South in June of 2013, 2 years post-Wallow. The left-hand photo is the normal color photography, and the right-hand photo is the infrared photography. And the main message here is that this particular treatment allowed 95+% survival of the residual trees post-treatment. So these treatments do work with uncharacteristic fire, according to our experiences here. And the Eager South example validates and demonstrates the effectiveness of restoring forest composition and structure in facilitating the spread of surface fire instead of uncharacteristic fire. So let me emphasize again, the whole thrust of this is to have fire occur naturally as surface fire, low severity, and frequently. Go ahead. Okay, let's do a little quick review of the GTR. The GTR paints a vision that we feel we should move toward in the Southwestern region. It's heavily informed by HRV and best available science. It restores key elements and their arrangement in space and time. Allows resumption of characteristic processes and functions, improves forest ecosystems' resilience and resistance, and identifies the importance of scale, fine, mid, and landscape scale. In addition, the GTR provides a guide to address site-specific variability and management flexibility. It acknowledges that it may take time and multiple entries to achieve restoration. And it recognizes that restoration must adapt over time as we learn from implementation and new science. It results in many added benefits. Those benefits including improved habitats, improved biological diversity, food webs, hydrologic function, wood products, visual qualities, and fuels reduction, as well as increased resistance and resilience to climate change. Our goal is to restore and sustain the key elements of frequent fire forests and their spatial and temporal arrangement to give us the best chance of allowing resumption of natural processes and functions. Implementation challenges. Improving efficiency in layout, task order preparation, and treatment execution. We have to get more efficient at preparing these areas for treatment. We can't use traditional mark every leaf tree that will be left in order to deal with the large acreages that must be treated. We need to obtain better public support for openness in large tree issues. Openness called for in the GTR is much greater than you see on the land today. These forests are way more dense than they were historically. We're calling for a much more open forest condition. In addition, folks are concerned about removal of large trees. We have to carry the message that in order to restore these lands, we must remove some of the large trees in order to create grass forest shrub interspace. Designing landscapes to provide for T&E species, corridors, wilderness areas, and other values while restoring forest resilience. Prioritizing landscapes and strategies for achieving restoration. We can't get to all these areas for treatment purposes in 1 year or even 2 or 3 seasons. It will take us a long time to get there, so we must select those that are of most important to us and do those first. We need to address operational feasibilities that limit restoration treatments and view landscapes as dynamic and sustaining key elements over time. Once we do a restoration treatment, they won't stay that way. They'll require maintenance. We'll have to follow with fire to help maintain those things over time, and possibly additional mechanical treatments. Research needs, among the many. One of the things that the author team was in unanimous agreement on is that we need a lot more information than we have. And so I'd just like to talk about a few of our research needs. We need to expand our knowledge of reference conditions across ecological gradients and in large landscapes, not just small areas. Has to be looking at large landscapes. We need to improve understanding of historical difference between ponderosa pine and dry mixed conifer, the historical types, the frequencies, the severity of disturbances, and the vegetation responses. We need to have better knowledge of the mechanisms for spatial pattern formation and determine responses of frequent fire forests to restoration treatments. We need to look at the efficacy of the tools that we have, fire alone, tree cutting alone, fire and tree cutting, at achieving key restoration elements. And we need to implement the new findings within an adaptive management framework. GTR 310 is a synthesis of the science, and it paints the way, it points the direction and the path to move toward. It's not the end-all, the final answer. It is another step along the path to restoration. As we learn more, we must adapt and apply it. And with that, we'll open up the discussion for any dialogue or questions that you might have.
Great. Well, that was an excellent presentation. You covered a lot of ground. We've already had some questions and some back and forth in the chat window. And in case people weren't watching the chat window, I wanted to just take a second and highlight some of it. And maybe first we'll turn to Noelle's question about temporal considerations. So she asked about, let's see, site-specific information regarding the timing of treatments, natural disturbances, and how the timing influences the effect of disturbance on species composition, structure, and consequently function. And Tessa started to answer this a little bit, but maybe, Tessa, do you want to jump in and kind of expand on your answer verbally?
Yeah, sure. Hopefully everybody can hear me okay. So that's a really good question, and timing is really, really important when we start talking about disturbances, especially with how that affects the subsequent disturbance within that area. So when we talk about timing, there's basically two things that come to mind. One is the frequency of fire, so how often a disturbance, in this case maybe fire or disease in insects, occurs on a landscape. The other part of timing is in what season, so in what stage of plant physiology are these disturbances affecting these landscapes, and what does that mean for that landscape? So I'll touch a little bit on seasonality first. So we know in the Southwest that our historic fire regime, and this is based on tree ring data for the most part, and of course our lightning occurrence, tends to occur pre-monsoon. And in some areas that can be as early as March, and in other areas it's not until maybe June, and then all the way through July, depending on when our monsoon's set up. And then we can see some fires again with some lightning patterns and some drier conditions across the Southwest in the fall. But that's a little bit to a lesser extent. So what that basically tells us is that for the most part, fires tend to occur once or right before our green up that's associated with monsoon. So that has some consequences for plants and animals, of course. And Noelle, you were also interested in looking at your breeding seasons and your restricted seasons for wildlife. I think I remember you saying that. So if you think about seasonality, the MSO breeding season falls right within our peak fire season. So that has some interesting thought processes with it there. We don't know much about effects of seasonality. So we tend to put our prescribed fires in the fall and then the spring in conditions that give us better chances to control that fire and have better precision in meeting objectives. But we don't fully understand what that might mean for our systems. Then I'm going to move on just a little bit to frequency now. So we talk about frequent fire forests, and for the most part that means that we're looking at forests that saw some kind of disturbance every 2 to 24 years in these two types of forests. But what that means, it doesn't mean that the tonal rim area where we see a high frequency of fire, so more towards the 2 to 5 year frequency, that doesn't mean that we saw fire every 5 years like clockwork on these landscapes. It was pretty variable. So we might have a gap of 6 years somewhere in there. That's very important for tree regeneration and the accumulation of different fuels. So if we see that gap of 6 years, that allows a seedling to be 6 years old and might survive the next fire, but might be right adjacent to it. It might mean that we see the accumulation of fuels over 6 years underneath some regeneration patch, and the subsequent fire would then kill all of those and create more of an opening in that area. So that's a little bit of that feedback loop where we see fire kind of control regeneration and at the same time provide areas for future regeneration. What I mean by that is areas that have logs or a high concentration of fuel are going to burn with a higher intensity when that fire does come across, and create a patch where we won't have as much fuel for the next fire. And that area then becomes a safe site for our regeneration to come in and grow before the next fire can move through there. So it's a pretty complex spatial interaction with how often fire occurs on these landscapes. One more thing, I'm going to go back to seasonality for just a second. We talk a lot about herbaceous fuels, so grasses, forbs, as a carrier of fire, and that's true. What we also need to talk about is how needles differ in how they carry fire. So needles tend to carry fire in situations when grasses might not. So as we see the relative humidities rise with monsoon patterns coming in, so we see more moisture in the air, some of those grasses may not carry fire anymore, or not very well, while needles tend to carry fire through those conditions very well. And that allows areas underneath trees, so mature trees or overstories where we have a lot of needles and cones, that kind of thing, those areas will still carry fire, while areas right next to those where we have grasses might not. So again, we have safe sites being created based on the difference in how different fuels carry fire. So hopefully that answers some of those questions, and I hope I haven't muddled the waters here, but feel free to ask follow-up questions to that.
Thank you, Tessa. And since we have 96 people on the phone, I'm a little hesitant to unmute the line because I think there may be a lot of background noises and hard to hear people. So I think we'll aim for getting most of the questions via the chat window unless we have some problem and somebody needs to talk. I would follow up on that. Tessa, is there a particular, or maybe you could even put it in the chat window, is there a particular resource or, I don't know, set of GTRs or something that you would recommend Noel or others interested in this seasonality question look into?
Yeah, you know there are, and what I'll do is I'll send those out if that's okay with Noel. Yeah.
That'd be great. Thank you. And let's see, trying to pick up some of the other questions that came through early on. Let's see. We had, let's see, well, there was one about the burn severity and Las Conchas, and I think Tessa actually did a good job of answering that a little bit, and there are some good maps of burn severity online. So I think we may jump to maybe a more convoluted answer, and that is that the link between the GTR 310 and the cohesive strategy. And Tessa, I think you did a nice job of answering that in the chat window, but I don't know if you or somebody else wants to sort of summarize that a little bit and highlight those links again.
Okay, yeah, so I can just kind of reiterate what I said there. So the cohesive strategy basically consists of three main strategies. The first is to restore and maintain landscapes, and within that, that means that landscapes across all jurisdictions are resilient to fire-related disturbances. Then we have fire-adapted communities. So that means that human populations and infrastructures can withstand a wildfire without loss to life and property. And the third one is wildfire response. So all jurisdictions participate in making and implementing safe and effective, efficient, risk-based wildfire management decisions. So all three of these need to be linked by science for the cohesive strategy to work. So GTR 310 is one of the best avenues for science related to these frequent fire forests that then speaks to how to restore and maintain these landscapes and make them more resilient to fire-related disturbances. So it directly hits that first strategy I spoke about. And it also ties into wildfire response. So how can we respond to wildfire in a way that might promote fire as our disturbance regimes across our landscapes, and then in turn make for fire-adapted communities. So I see GTR 310 as being very ingrained in how the cohesive strategy is put about.
Great, thank you. That was very well answered, nicely succinct. Now the next challenge for the authors is Carolyn Enquist had a question about the lengthening growing season in the Southwest, particularly the early onset of spring. And she asks, are fire managers thinking about changing burn windows and the change in potential effects on vegetation? So I don't know which of the authors would like to tackle that question.
Well, I can start, I guess, since I'm on a roll here.
Great.
So in the Southwest, when we talk about these frequent fire forests, we're talking about forests that historically were fuel limited. And what that means is that historically in the Southwest, we had a lot of times where we had hot, dry, windy weather. It's not abnormal for us to see that type of weather even this time of year in the Southwest. But what really limited fire growth in these types of forests was the availability of fuel. So there was so much fire across these forests that they just didn't carry fire because there wasn't enough fuel to carry fire. If you ask a manager if they've put a prescribed fire one year and they try to burn it the following year, it won't carry. It just won't carry that fire. Or if it does, it's very minimal and patchy. So if we think about how historically these forests were fuel limited and not weather limited, the lengthening of a fire season is not as big of a concern if we were back in that condition. Now, when we talk about forests that are higher elevations, that are not fuel limited forests, but that are more climate driven forests, those are areas where we'll see some changes with that lengthening of fire season. And those forests are like subalpine fir, wet mixed conifer forest, where we have a lot of fuel, and it's pretty consistent across these forests, but it's the climate that dictates when that fuel is available to burn. And so if that climate changes or lengthens, then we'll see those fuels available more often than they have historically. Hopefully I've somewhat answered part of that question.
Yeah, that was good. Any other authors want to chime in and add to this discussion? Essentially, it's a discussion of climate change and its effects on fire season.
Relative to the discussion of lengthening fire season, I mean, Tessa correctly described how these systems were historically fuels limited, and that is correct under the characteristic conditions. But under the current conditions, we could obviously see impacts due to a lengthening fire season.
But we're seeing them already. We don't even need a lengthening of the season to see that.
Yeah.
Right.
Okay, and maybe we'll turn next to a question that Don Carter put in, and he's asking about the link between bark beetles and low-intensity fire. And he asks, do you feel that low-intensity fire will address the boring beetle problem?
Hey, Don, this is Andy Graves here. Can you hear me? Or can you guys, the rest of you guys hear me?
Yeah.
First of all, the beetles aren't boring. I'm just kidding. But the main, the main thing that I think will happen is when we get these frequent fires, and I don't think that the frequent fires will necessarily be low intensity, but they'll be patchy, and that in some cases those fires will kill trees and thin out the forest. So my thought, and we don't have a lot of evidence for this historically, is that continual frequent fires that have been recorded and have been surmised for the history of the Southwest will lead to thinner stands, healthier stands, and more resilient stands that are also heterogeneous with a wide variety of both densities, age classes, and size classes of trees. And my feeling, based on what we know about bark beetle biology, is that this will lead to a higher level of resiliency to bark beetle outbreaks. We'll still get stands of trees that are killed by bark beetles, but the hope would be that with this heterogeneity on the landscape, that you would have patchy bark beetle outbreaks rather than large-scale outbreaks that have been seen up in Colorado, for instance.
Great. Good to have the beetle expert on the phone. And we'll move right along. Let's see. Noel actually had sort of a follow-up on shifting paradigms on forest openness, and they could be easily compared to shifting paradigms on smoke. And she asked if there are any plans to address that. And I think it's sort of a smoke management question.
Yeah. So this is Tessa again. I'm sorry, I'm yapping over here. But the smoke is a big issue. Really, it comes down to we're going to have smoke, and how do we want it? But it's more of a public issue and a political issue to some extent. And so how do we deal with communities that might be sensitive to smoke and have to deal with smoke in a way that allows for fire to still play its role on these landscapes, and not be a detriment to these areas. And that's a big challenge. And a lot of it might be education, because smoke is going to happen, like I said, and how do we want it? Do we want it from high severity fire, or do we want it from a fire that's caused compositional changes to these forests? That's a very big challenge right now in the Southwest, and we're trying to address it. Any suggestions would be greatly appreciated.
And I can't resist adding that the Southwest Fire Science Consortium is putting together a smoke conference for later in the year. And so if that's a topic that interests you, I urge you to stay involved with the consortium and sign up for the email alerts so you can hear about when, as that conference comes together. And maybe Barb is still on. She could put, we might have a link to preliminary information already. So if there are other questions out there, I think we've exhausted what was in the chat window, but if I've missed one, maybe we can, you could retype it or copy and paste it again, so we make sure to answer everybody's questions. And if you still have a lingering question, please do put it in the chat box. Good. Barb came through with the smoke workshop info. So for those of you for whom that's really the major focus, please do check that out and get involved. Well, I don't see a lot of other questions coming in. We'll hang out here for a little bit, but we are coming to the top of the hour. So for people who need to leave and get to other things, feel free to go ahead and drop off, and we look forward to seeing you at the event in Tucson coming up. And it looks like Winston Craven has his hand up, but that may not be on purpose. So Winston, maybe if you can just type your question or your comment in the chat window, that's probably the best way to do it. Good. We can always count on Pepe for a question. So Pepe's question is, how much of this is dependent on getting a timber industry in the Southwest? So how much of the sort of thinking and planning or ideas in GTR 310 rely on having some sort of timber industry? Maybe that's one for you, Jim.
So I'll take a crack at it. I don't think, first of all, I wanted to clarify that, this document describes desired conditions and functions, and it doesn't describe how you get there or how you maintain it. And I think that's going to be based upon management strategies of individual units, individual agencies, individual managers. I think in some cases, based upon existing conditions, it's going to be very difficult to get there, to get to an initial condition where we can restore frequent surface fire without some mechanical types of treatments. And on some locations, it may be desirable to have periodic mechanical treatments, say every 30 to 40 years, in addition to frequent fire. It's more or less based upon local management objectives. But I do think when we look around the region, and particularly when we look at these areas that had experienced railroad logging back in the late 1800s, early 1900s, we're looking at stands of trees that are now 90 years of age. And I know that there's been an awful lot of studies on the experimental forest trying to thin these 90-year-old trees with fire, and we have not been real successful. So I think this is a huge challenge. And I don't think there's an answer to this question, but I think that having some level of utilization is going to make this process much easier to obtain. It doesn't mean that we can't do it, and we do have examples around the region, in Gila Wilderness, in places where they've not had fire suppression for such a long period of time, and they have forest that's easier to start to move down this path with fire alone. But I think it's going to be a challenge to do without having some some utilization.
And there was another question about whether some of the authors are going to be in Tucson for questions, and yes, I believe a number of them will be, and certainly this is a key focus of the conversation in Tucson, so hopefully we can get more of your questions answered there. And I think that basically wraps up the questions in the chat window. Tessa's going to respond to Julie's question, and Barb has been kind enough to post the recording link for the climate change webinar, so people can get that there or the website as well. And I guess unless one of the authors has anything else to add, I'd like to wrap it up here and thank everybody for participating. So Pat or Jim or Tessa or anybody else want to say something before we close?
I'd like
this
to
is
say
Andy here. Go ahead, Jim.
And that is anyone who would like to visit some of our demonstration areas, the areas where we've done these implementation, the Blue Water or the Eager South, if they could contact any of us, we can probably make some arrangements to do that, because I think it's very different to actually walk through these areas and experience them, particularly Eager South, post fire, and to look at the surrounding landscape and to see how fire behaved in that. So I'd just like to throw that out, and this could be something that the consortium could look at doing in the future.
And my comment was going to be to offer Jim to give any of those tours, and then secondarily to let anybody know if there's other questions on any of the specific aspects of the manuscript that were available by email and continual discussion, whether it's just a question or whether it's a criticism or a reiteration or whatever. The emails are all on this page right here. Feel free to contact any of us.
Great. Well, thank you. And thanks again, particularly Pat, for a great presentation, and I look forward to seeing everybody in Tucson. And with that, I'm going to close off the phone line and shut down the webinar, and we'll post the recording as soon as we can. So thanks, everybody.